Hello everyone, welcome back to Cloud Safari series. Want to deploy your app to the cloud in minutes without all the server hassle? Meet AWS Elastic Beanstalk. So in this video, I'll show you how to go from code to a fully managed cloud environment in just a few steps. So let's get started. So first, let's talk about what Elastic Beanstalk actually is. Think of it as AWS managed platform for deploying applications. It handles the heavy lifting, provisioning, load balancing, auto scaling, and also the monitoring. So you can focus more on your code and less on infrastructure. With Elastic Beanstalk, you simply upload your application code and the service automatically handles the deployment, including resource provisioning, load balancing, scaling, and monitoring. It supports a variety of programming languages, frameworks, and platforms such as Node.js, Python, Java, .NET, and Docker. Elastic Beanstalk automatically adjusts the resources required based on your app's traffic, ensuring high availability and performance. It integrates with other AWS services like RDS for databases and CloudWatch for monitoring to help you easily scale and manage your application in the cloud. So let's go through AWS Elastic Beanstalk features. First one is wide selection of application platforms. So it supports varieties of programming languages including Java, .NET, Node.js, PHP, Ruby, Python, Go, and Docker. Second point is variety of application deployment policies. It offers several deployment strategies to ensure a safe and smooth deployment, including all at once, rolling with an additional batch, immutable, and blue-green deployments. Third point is monitoring. So it integrates CloudWatch and Xray. So with integration, you get access to real-time performance metrics like latency, CPU utilization, and response scores. So fourth one is updates and management. Elastic Beanstalk allows you to automatically get the latest platform versions and security patches with managed platform updates. Fifth feature is scaling. Elastic Beanstalk automatically adjusts the number of running instances using elastic load balancing and auto scaling, responding to changing traffic conditions. Sixth feature is customization. Elastic Beanstalk gives you flexibility in choosing AWS resources such as EC2 instance types, including spot instances to optimize for cost and performance. So these are the features of Elastic Beanstalk. Now understand the deployment strategies in Elastic Beanstalk in little detail. So first one is all-at-once deployment. As the name suggests, with this strategy, Elastic Beanstalk deploys the new version of our application to all instances simultaneously. Second one is rolling deployment. So this strategy deploys your application incrementally, updating a few instances at a time. Elastic Beanstalk waits for the updated instances to pass health checks before moving on to the next batch. So third deployment strategy is rolling with additional batch deployment. Similar to the rolling deployment strategy, but with an extra batch of instances updated simultaneously. This means that while the regular rolling update is happening, one additional batch of instances is updated at the same time, reducing the overall time of deployment. Fourth deployment strategy is immutable deployment. This strategy creates new instances with the new application version and routes traffic to those ones they are healthy. The old instances are not updated but are replaced entirely. Fifth deployment strategy is blue-green deployment. This deployment strategy involves two separate environments, blue and green. The blue environment is a live production environment, while the green environment is a clone of the production that you deploy your new version to. So we will configure the infrastructure using Terraform. So let's understand about Terraform. Terraform is a powerful tool to provision and manage the necessary infrastructure in an automated, efficient, and repeatable way. Terraform allows you to define your Elastic Beanstalk environment along with all the supporting resources such as S3, load balancer, auto-scaling groups, IAM roles. By using Terraform, you can standardize infrastructure, automate deployment, handle scalability, and improve efficiency. Now it's demo time. I'll walk you through a Terraform setup that defines and manages AWS Elastic Beanstalk resources using modules. So let's dive into the code. So this is Terraform code. As you can see in the left hand side, there are extensions .tf or .tf file is a configuration file used in the Terraform. So there are several files. This is load balancer, this is backend.tf to store the tf state of Terraform, this is data.tf file, this is Elastic Beanstalk, locals, naming, outputs, pro.tf vars, this S3 means S3 bucket, SZ security group, then variables, versions, and then VPC. So the first module, Elastic Beanstalk application, is here. So it creates the Elastic Beanstalk application. It uses local variables for the application's name and description. So in locals, we can actually see it here, Elastic Beanstalk naming. So the name is coming from the naming convention, and this is the description provided for the Elastic Beanstalk description. So this is the first part. Next, the Elastic Beanstalk environment module sets up an environment under the application. Here's what's happening. It sets the environment name, description, and reason. This uses a shared load balancer with health checks pointing to the root URL. After that, it configures the instance type, root volume details, and an auto-scaling setup. Auto-scaling adjusts the number of instances based on performance metrics like CPU or memory usage. For the networking part, the environment is connected to VPC subnets for public and private access. So it is using rolling updates. Updates are handled seamlessly with options to minimize downtime. Now, the solution stack in here, it defines the platform such as Node.js or Python or any programming languages. But for this demo, we are actually using sample Node.js application. Moving forward, security groups. A security group is attached to manage access for the instances. Additional policies ensure the environment has minimal access to required S3 resources. Dependencies are carefully managed, like waiting for the application load balancer to be ready before creating the environment. In summary, this Terraform setup automates the creation of Elastic Beanstalk applications and environments with flexibility for scaling, security, and networking. It's modular, so you can reuse and customize it for your needs. In the first job, Terraform infrastructure checks out the code from the repository, configure AWS secrets stored in the GitHub secrets, and then initializes Terraform using Terraform init, and then plans the infrastructure changes with Terraform plan, and applies them using Terraform apply. And this destroy is used to destroy all the infrastructure that has been built after applying the Terraform. In the second job, build and test, which depends on the first job, Terraform infrastructure, we are again checking out the code and then configuring AWS credentials, sets up the Node.js, list files before zip, and then we are zipping the Node.js application. And then we are uploading that zipped file to the S3 bucket. Similarly, in the final job deploy, after the application is built and uploaded to S3, it deploys the application to Elastic Beanstalk by creating a new application version. We are creating the new application version using this. And then it updates the environment using AWS Elastic Beanstalk update environment with the newly created version. The deployment is tagged with a timestamp as a version label to uniquely identify each version. Now that the Terraform configuration is ready, let's save and push these updates to our Git repository. I'll walk you through the process step by step. First, I'll run git add. This command stages all the changes we have made in our working directory for the next commit. Think of it as preparing your changes to be saved permanently. Next command is git commit. So we can also add a message in here. Deploying Node.js application. So a commit is like taking a snapshot of your work. And finally, the command git push. So it will changes to the remote repository using git push. This uploads the snapshot we just created to the shared repository so others can access the latest update. Now the changes are live in the repository and we are ready to continue our workflow. So that's the full process for saving and sharing your changes using Git. Stays with Git add, commit with Git commit, and push to the remote repository with Git push. Simple and effective. So let's go to this console. So here we can see that everything has been done. So it has been deployed to the Elastic Beanstalk. Now let's navigate to the console. Let's go to Elastic Beanstalk. So let's open it. From the dashboard, I can see the application we just deployed listed under the application tab in here. On this page, we can see the details of our application, including the environments associated with it. Right now, we have one environment and its health status is displayed as OK, which means everything is running smoothly. The URL of our deployed application, health monitoring details in here, configuration settings, including the instance type, load balancer, and scaling setup. Everything matches what we defined in our Terraform code. Finally, let's test the deployed application. I'll open the application URL provided here. And there it is. Our application is live and running. This was the sample Node.js application. That's how you can verify and test your deployed application in the AWS Management Console. Elastic Beanstalk simplifies the process and Terraform makes it easy to automate the setup. Thanks for watching, and I hope this demo gave you a clear understanding of how to deploy and manage application on AWS Elastic Beanstalk with Terraform. See you in the next video.